Good afternoon. The purpose of this experiment is to determine unknown metals. It will be performed by finding the density of the unknown metals. The problem is you have a summer internship working in a jewelry laboratory where your job is to explore the properties of some alloys of silver, rhodium and platinum in order to make brighter jewels at a lower cost. One day while preparing an alloy you accidentally left the bottles near the melting furnace and the labels become unreadable. Oh no, you now have 3 unlabeled bottles of metallic powder. Our task is to design and perform an experiment to identify the metals in these bottles. So, to identify the metals, we will be finding the density of each unknown metal. So they give us the density of silver, which is 10.5, the density of rhodium, which is 12.4, and the density of platinum, which is 21.45. So they give us that so we could compare the ones we find. So to start with, I will be pulling out a scale, pulling out my weighing board, put my weighing board on my scale, press the tail button. Now I'll be taking my metal 1, pour some of the metal 1 on the weighing board, pour to pour. So I poured 52.59 grams. So we're 52.59 grams. So we write that down. Now we could remove this. We could disconnect this. Here in our weighing board we still have the mass. So we could remove this. Get our distilled water, and I will be using a graduated cylinder of 100 ml. So we pour some water on our graduated cylinder, pour to pour. I poured 63.16 ml. That's the volume of that the graduated cylinder contains right now. So we could remove this now. Pour our metal 1 onto the graduated cylinder, hold to pour everything. So the new volume of the graduated cylinder is 67.4 milliliters. So we know that to find density is mass over volume. So we know the mass is 52.59 grams, and the volume is the difference between the new volume and the old volume that we had. So the difference between 67.4 and 63.16 is 4.24. So we divide 52.59 divided by 4.24, which will give us 12.4. That's the density of metal 1. So we come here and see which one is closest. The closest one is rhodium. So metal 1 is rhodium. Now we could use this same weighing board. Do the same procedure. Take our scale, put our weighing board on the scale, press the tail button, take our metal 2, pour it, pour to pour. I poured 56.18 grams, so we write that down. Now we could remove this, disconnect this, remove this, take our distilled water and a graduated cylinder, pour our distilled water on our graduated cylinder, pour to pour. So I poured 63.86 milliliters. So that is the volume of the let's say the old graduated cylinder. So now we could remove this distilled water, add our metal 2 on the graduated cylinder, everything. Now the new volume of the graduated cylinder is 66.5 ml. So we know that the density, to find density is mass over volume. So the difference between 66.5 ml and 63.86 ml is 2.64. So we divide 56.8118 divide by 2.64 equal 21.28. So the density of metal 2 is 21.28. So we come here and see the closest one. The closest one is platinum, so we know that metal 2 is platinum. We could remove this. Do the same procedure for metal 3. Get our scale, put our weighing bolt on it, press the tear button, get our metal 3, put it, roll to pour. I poured 38.52 grams. So we could remove this now. Remove metal 3. Here in our blowing bolt we still have the mass, so we could remove the scale. Get our distilled water. Get our graduated cylinder. Pour our water on the graduated cylinder, pour to pour. I poured 41.00 ml, so 41 ml. Could remove this now. And pour our metal 3 on our graduated cylinder. Pour to pour. Everything. So the new volume of the graduated cylinder is 44.7. So the difference between 44.7 and 41.00 is 3.7. So we know that 38.52 divided by 3.7 will give us the density of metal 3. So we'll do it, the calculation. 38.52, it's 10.41. So the density of the last metal or metal 3 is 10.41. So we know that 10.41 corresponds, the closest one is 10.5, so the closest one is silver. So metal 3 is silver. Now let us check. Yeah, that's correct. Thank you.